Welcome back, dear all, on our next session on centrifugal tensions in the belt drive. So first, what is centrifugal tension? We know that the belt moves from the driving pulley over the driven pulley. So the belt wraps around the pulley over here on the driving pulley as well as over the driven pulley. So due to the rotation of the pulley, the part of the belt which is in contact with the pulley over here, that is also rotating along with the pulley. As the belt is rotating, so due to rotational motion of the belt experiences a centrifugal tension. The centrifugal tension is always a centrifugal force. That centrifugal force is always away from the center of rotation. So center of rotation is the center of the pulley. That's why the centrifugal force will be moving away. It is directed away from the center of the pulley. So due to this, the belt is somewhat pulled in the direction away from the pulley in the outward direction. Due to this, the belt which is over the top on the and over the bottom over here, so the belt experiences some additional force over the driving pulley due to centrifugal force on the driving pulley as well as on the driven pulley. So due to rotation of the pulley, the belt rotates and that causes a centrifugal force on the belt. That centrifugal force results into the increase in the tension on the tight side as well as on the slack side of the belt. The tension caused by the centrifugal force is called as centrifugal tension. When the belt speeds are less than 10 meters per second, then the centrifugal force is considerably low. That's why centrifugal tension caused by the centrifugal force is also low. That's why we can neglect when the belt speeds are lower, but when the belt speeds are higher, then we have to consider the effect of centrifugal force in the belt tension. Considerably, the belt tension increases due to centrifugal tensions in the belt. That's why we have to consider the effect of centrifugal tension when the belt speeds are higher than 10 meters per second. So centrifugal tension is given as TC. C stands for centrifugal, T stands for tension. So centrifugal tension is equal to mv square. So the notations are important here. M is mass of the belt per unit length. So it is mass per unit length in kg. That means the unit of this M is kg per meter. So mass in kg and length is in meter. So unit of M is kg per meter. You should remember this because normally we take the notation of M as mass only, but in case of belt drive, the notation of M indicates mass per unit length. Then velocity V is in meter per second, so it is velocity of the belt. It is normally given as pi d1 n1 upon 60 or pi t2 n2 upon 60 as we had seen earlier. When the centrifugal tension is considered, then the simultaneously tension on the tight side as well as tension on the slack side gets increased. So tension on the tight side the total tension on the tight side will become T1 plus TC, whereas the tension on the slack side will become T2 plus TC. So TC is additional tension which is added upon on the tight side as well as on the slack side. One thing you should remember, that centrifugal tension doesn't affect the power transmitted. That means the effect of centrifugal tension does not increase the power transmission capacity of the belt drive, neither it reduces the power transmission capacity of the belt drive. So the power formula will always also remain same, that is power is equal to T1 minus T2 into V. In this T1 and T2 you need not to consider the effect of Tc. So T1 is normal tension on the tight side and T2 is normal tension on the slack side, and V is the velocity of the belt. This T1 is excluding the centrifugal tension. This T2 is also excluding the centrifugal tension. And T1 upon T2 is equal to e raised to mu theta, that is limiting tension ratio. It also remains same. So T1 upon T2, so it is a normal tension on the tight side and it is normal tension on the slack side. So T1 upon T2 is equal to e raised to mu theta. So in both the formulas there is no effect. That is, in the power formula as well as in the limiting tension ratio formula, there is no effect of centrifugal tension. It will be only considered while assessing the stresses in the belt or forces in the belt, and due to this the life of the belt may get affected. Thank you for this session.